And these, I believe, are the 4 main reasons for failure in this section in the IStructE exam.
Hi everyone, I'm a chartered structural engineer with over a decade of experience working in the UK in designing buildings, and I passed my IStructE exam a few years ago. And today I'll be going through the IStructE past paper 2024, July 2024. I'll be going through section 2C, the structural calculations. Basically, I'm going to go through the calculations on how I would do them for this exam for the main items of the design. The main items are those that are singular to structures such as cantilevers, large trusses, any transfer structure or hangers that are not common, not just columns and beams. First thing that you start with is normally the load takedown. You work out what the loads are. They can be just estimate loads. If you just give a typical allowance for services and finishes, then it should be sufficient. The same for the wind load. An approximate wind load normally is 1.2, 1.4, 1.6 or so, depending on the location where you are, if it's really windy or not. For the calculations, it's always a good idea to have templates. For all the sections, actually, it's a great idea to have templates, but especially for the calculations and the drawings is where I find the templates are the most useful. They are a great reference to use as a guidance and allow you to just complete the calculations much faster. So once you have identified which ones are the main structural elements in your superstructure, and of course the type of foundation, then you can work out the load takedown for each of those elements.
I think it'll be important to show what are the main reasons for failure. And these, I believe, are the 4 main reasons for failure in this section in the IStructE exam. First one is doing calculations of regular members rather than singular or main structural elements. So anything that is regular members rather than singular structural members, you should just size them with span depth ratios like beams and columns, etc. Just use tables if you need to. Second main reason for failure is not doing the foundation design or foundation calculation. Third reason is not considering the serviceability, especially for large spans, cantilevers, other elements where deflection tend to be the most onerous case. And finally, and is for the new exams in 2024, in this case it wasn't included, but from 2025 onwards it is not doing the embodied carbon calculations. This is something that IStructE is asking for now, and it will be one requirement.
The most important thing to remember in this section is to show that you know how to identify the worst case scenario for each of the main structural elements and each singular case. For example, for the wind load, then you know which one would be the worst case scenario. For the cantilevers, which one would be the worst case scenario for the truss. And so you don't have to do all the checks in all the cases, but just to identify which one is the worst case, and then do the calculations for that one. One of the main reasons for failure is to do the calculations of regular members only rather than the singular or main structural elements. So you want to avoid doing calculations for columns, beams, and any other typical structural elements such as floors or purlins.
In this case, for example, what I'm working out is the capacity of the truss. And trusses normally resist bending moment via the top and bottom chord. So you get a couple of forces, the results from the bending moment or the downwards or upwards forces applied to along the length of the truss. That creates a bending moment that is then distributed as a couple of forces, or can be distributed as a couple of forces between the top and bottom chord. The worst case scenario is always between tension and compression of the same magnitude. It's always the compression. So I check the actual compression, the capacity of it, just following the typical capacity resistance to compressive forces and buckling following the Eurocodes. And then the next check is the serviceability, to make sure the deflections of the truss are not excessive. And this is really important because the truss has such a large span, the deflections tend to be one of the biggest constraints. To work out the deflection, similar to what I've done previously in all the videos, is I use the parallel axis theorem. You know the inertia of the top and the bottom chord, and you just need to work out what the inertia of this combined top and bottom chord are. Next item to check for me is the cross raising. Now, I think this is one of my favorite items to select for calculations. And it's because you normally have cross bracings in any steel structure that you use. Unless you decide to go for moment connections, then you end up having some type of bracing. Even though the cross bracing is a typical element, like a column or a beam in any structure, I focus on checking the capacity of the connection. As a result of the high wind loads, you'll have high forces in your bracing, and then the connection to them tend to be the weakest points, and that's because the connections tend to be done by a flat plate, regardless if it's a flat cross bracing or if it's a circular hollow section. The connection to the bottom or to the corner of the column tends to be via flat plate. And I found that pairing shows that, okay, I understand what the weakest point of my bracing is likely to be. The rest of the bracing will be stronger than this part of the plate. And tearing, it's a relatively simple calculation, and it's easy to templatize. You just need to work out the area is going to be under tension, the area is going to be under shear, and then you can work out the capacity for tearing. In your exam, I suggest you don't copy this in case other people are doing it too. Just find what would be a similar calculation that you could do, that you can have a template for, and then can adapt and use in your exam. And finally, the structural calculations of the foundation. In this case, they're pile foundations. The foundations must always be calculated. Always. Even if it's just part of the foundations. For example, in this case, I am checking the pile of the foundation. I am not going to check the pile cap. And if you notice, in my calculations, I try not to write intermediate units. At least that's how I decided to do it in my exam. And it definitely helps to save time and to feel less tired when writing so much the entire day. by the end of the calculations, if I got time, then I write a summary. I like to write a summary of the main items that I calculated and what the output was for the examiner and also for me, because when then I had to do the drawings, it was really useful to just go to my summary and say, okay, these are the final sizes that I took. If you have any questions or that you would like me to answer, or the will be a very useful video, then let me know, especially in the comments, and I'll try to read them and respond. And if it's a very good question that can be answered in a video, then I'll probably do a video about them. All right. Anyway, and that's it for today. I hope it was helpful, and I'll carry on with the next section from the next video.